This video is on adding solutions together and how we perform molarity calculations if we have indeed done just that, adding two solutions together. So let's say I have a solution of 1 molar NaCl 100 milliliters, like in my first beaker, and then in my second beaker I have a 2 molar solution of NaCl, also 100 milliliters. So the question becomes, what if I dump these two solutions together into my new beaker? How would I determine the molarity of the NaCl in this new beaker? So without doing any math here, this is just a conceptual discussion of the fact that when we're talking about adding solutions together, there are two quantities that are additive, and those two quantities are volume. And volume is additive because if you think about it, if you're going to mix 100 mils of one solution with 100 mils of a second solution, that would give you 200 milliliters overall. And so adding the volumes together would give me the total volume in the new container. There's a second quantity in solutions that is also additive, and that is moles. And so that means that if I could find the moles of NaCl in container 1, and then I could find the moles of NaCl in container 2, I could just add those two together, and that would be the resultant moles in my new container. And so volume and moles are both additive when we mix solutions together. However, molarity is not additive. And the reason for that is that molarity is a ratio of moles to liters, and that makes it not an additive quantity. We can instead calculate a molarity, but we cannot, like in this case, add the 1 molar with the 2 molar and call our new solution 3 molar. That goes against the laws of chemistry and adding solutions together. We can calculate it, we just can't add it together. So the next two problems that follow are examples of how we would determine the molarity of an additive solution. So in my first example, I have, and I'm going to draw the picture like I always do, I have a solution that was prepared by mixing 50 mils of 0.1 molar nitric acid with a solution also of nitric acid, but this time it's 0.2 molar, and it's 100 mils. So the question becomes, if we mix these two solutions together, what is the molarity of the HNO3 in this new resulting solution? And so we've already determined just above when we were talking that molarity cannot be added. So I can't take my 0.1 and my 0.2 and add them together. But I can calculate the molarity if I know the moles of nitric acid in my new container, and I know the volume. And so this is where the discussion becomes that moles and liters are both additive. And so in my first two solutions, I had 50 mils and I had 100 mils. And so when we add those together, I end up with 150 milliliters, which is 0.15 liters. And that would be the new volume of the new solution once they were mixed together. Then to finish my molarity calculation, I would need to calculate how many moles of HNO3 were in container 1, and then how many moles of HNO3 were in container number 2, and I would then add those together to get my total moles in the new container. And so, of course, we know molarity is moles per liter. So I can calculate moles by taking molarity times liters. This is in, we'll call it container number 1. In my first container, my molarity was 0.1. My liters were, well, my milliliters were 50, so 0.05 liters. Oops. And that gives me a mole value of 0.005 moles just from my first container. In my second container, I can do the same thing. My molarity was 0.2. My volume was 100 mils, which is 0.1 liter, and so my moles in container 2 were 0.02 moles. I now know the moles in the first container and the moles in the second container, and so when I mix those two together, moles are additive, and so I can add my 2 mole values together, and that is in fact the total moles of nitric acid that are in my container. Now I can just do my calculation. And I find that the molarity of this solution is 0.167 molar, and that would be my final answer for the new resulting nitric acid solution. Notice that this proves that molarity is not in fact additive, because had I added my 0.1 molar and my 0.2 molar, I would have gotten 0.3 molar, which is in fact not the molarity of the nitric acid after these two solutions were mixed. I should let you know that this is not a dilution. While it semi-resembles a dilution is one where we add water to a solution to reduce the molarity, and in this case I'm physically mixing two solutions together that already had molarities.